Now this graph does something that a lot of normal graphs do. It gives us two variables. It tells us, okay, we've got time flowing over here, much as you read it from left to right, just as you read music notation. You've got population, something going up and down, just like pitch does on the staff. In a lot of ways, the musical staff is just a graph for music, but it's a funny graph. Now, based on this nice straight line here, so we've got some imaginary town, and we look at how the population of that town has grown from the year 1800 to the year 1920. And looking at this nice straight line, I might say, oh, this town has experienced linear growth, and that is to say, 20 years here, however much the graph goes up, 20 years here, it goes up the same amount. So we've had nothing but linear, uninterrupted, even growth in the population of this town over the course of 120 years. Now, if I told you that on the basis of this graph, I would be lying to you. Take a look, take a careful look at that graph and see if you can figure out why that is. The problem has to do with the labeling of the scale. So population, 400, 500, 600, 700, 800, those are all evenly spaced. But now look at the years, 1800 to 1820. Fair enough, the population has gone up by the same amount during those years. It's gone from here to here. Now, 1820 to 1840, it's gone up by that same amount. And over to the next one, it goes up by that same amount. But wait a second. Look at the scale. I'll align this a little bit better. Look at the scale. This is 1850, 1800, 1820, 1840, 1850. Half as much time went by, but the population grew by the same amount as it did on each of those other chunks. So in fact, instead of a nice linear progression here, the rate of population increase has been much higher, twice as high, in fact, from 1840 to 1850. So this is, in fact, a very strange, hard-to-read graph. And if you look closely at the lower axis, you'll notice that there's a bit of music humor thrown in the labeling of that scale. Now, what I want you to understand is that this notation system, this graphing system of the musical staff, is as strange a graphing system as that population graph I just showed you. Because you would think, in a normal kind of a graph, that the distance from here to here, whatever that is, should be the same as the distance from here to here. And in that case, it is. The distance from there to there both contains the number of whole and half steps. But take, for example, this distance. That one would think in a normal graph would be the same as the distance from here to here. But no, this is a whole step. Note, whole, whole step between those two notes, and only a half step. So even though those look like they should be the same separation, the same distance, in fact, this distance right here is half of the distance from there to there. We're dealing with a warped space. Now, what that means is it puts even more weight on your process of learning to read these clefs. Because if I take away that clef sign, if I now have no clef, and I tell you, sing that to me, please, you should have no idea how to do it. Now, you might say, oh, but I don't know what letter names there are. Oh, don't worry about the letter names. Just pick anything. The same way you can start, I could write out happy birthday at a certain pitch level, but you could really choose any note to start on, and you can still sing happy birthday. You can do that with this, too. No, you can't. Because if this is all you've got, you know it's a whole step or a half step, but you don't know which. If I've got a treble clef, that's C and D, and it's a whole step. If, on the other hand, I've got a bass clef, that's an E and an F, and it's a half step. So in order for you to quickly be able to see what the relationships are between notes, it is essential that you memorize the note names and the relationships among these notes within each of the main clefs because you are dealing with a warped graphical notation system. Now, there are just two more things I want to do in this particular video. First of all, I want to introduce an important term, and that term is diatonic. Anytime I have a scale that uses that same collection of whole steps and half steps in the same order, whole, whole, half, whole, 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 half, but potentially starting someplace else. So whole, whole, half, whole, 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 half, and let's keep going, whole, whole, half, whole, 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 half. I can start anywhere. I can start right there. Whole, half, whole, half, whole. Wait, how many? 1, 2, 3, 4, 5, 6, 7, 8. There we go. Whole, half, half, whole. That can be a scale too. That's a diatonic scale again. Anytime you've got a bunch of notes that if they were lined up from the lowest to the highest in order. Now here's the key. They don't have to be lined up in this way. So for example, if I write that, I think I'm missing a few. Let's, what do I need? Yeah, okay, there we go. If I write those notes, they're not lined up in the order of a scale. But if you lined them up in the order of a scale, they would make a diatonic scale. So when you've just got a bunch of notes like that, instead of talking about a diatonic scale, I'm going to talk about a diatonic collection. Diatonic scale, diatonic collection, two handy terms for you to know. The final thing I want to do in this particular video is to give you some practice writing scales, because as you know, you can write a major scale on just about any note. Well, how do you do that? You do that by adding accidentals in order to create the desired pattern of whole and half steps. So let's start on A. What do I need to do to make this into a major scale? That's a scale that starts and ends on A, and I can just write that up. That's easy. So I'll sing it lower. A to B is a whole step, and we're happy. B to C is a half step, and we want a whole step. So what do? We raise that C to a C sharp using a sharp. So now A to B whole step, B to C sharp whole step, C to D, C sharp to D. Well, C to D was a whole step, so now C sharp to D is going to be a half step. So we don't need to do anything. We've got whole, whole, half. D to E, whole step. E to F, that's a half step. So again, E to F sharp to make our whole step. Now we want another whole step. So F sharp, if we'd had F, F to G would be a whole step. But now that we have F sharp to G, that's a half step. We want a whole here, so F sharp to G sharp to make another whole, and G sharp to A is going to be a half. So A, B, C sharp, D, E, F sharp, G sharp, A. I can start on just about any note, and just by adding sharps and flats to create the desired pattern, whole, whole, half, whole, 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 half, I can make a major scale starting on any note.